so let's invent two planes. I have a choice of two types of equations for that. Which ones do you want? The ones with the normal, yeah. If you start off with the other one, the one with the vectors are on the plane, yeah. Then you have to take the cross product of these two guys to get the normal. So we might as well get started with the other one. Okay, so let's write one equation for a plane. Come on.
X minus 2.
X minus 2. Y plus 3 plus 6 times
Z.
Yes, it's a Z.
Minus 0.
Minus what?
Minus 0.
Minus 0. Okay, so just Z. Is equal to what?
0.
Yup. Okay, that's plane 1. This was a bit weird too. Plane 1 dot dot. It's not as if P1 is equal to this. P1, if you want to call your first plane plane 1, there's no equal sign. That makes no sense. Okay, then plane 2. Some more inventing. I'm starting 7 times x minus 1 plus 5 times y minus 7 plus 9 z minus 11. It's a weird plane. Right. Okay, so where do they cross, if they do? Okay. Hello. What should we do?
Check if it's parallel.
Check if they're parallel. How do we do that? We've got two planes. Yeah. Take the normal vectors. Just check if the normal vectors are parallel. That's straightforward enough. What's normal 1? First normal vector for 3, 4, 6. Normal vector 2. 7, 5, 9. Okay. Those are the two normal vectors. Are they parallel? Are they proportional to one another? No. You need to say that on the homework. You can't just say the planes are not parallel. There's an explanation for that. This is not proportional to that. The mic is on, so if you could avoid this. Thanks. In general, it's alright, but we're taping this. It's going online. Okay, N1 and N2 are not proportional, therefore the planes are not parallel. Therefore what? Therefore they cross. Okay, that's like the full reasoning. Let's check where they cross. So those are the two planes with the normals. We know they're crossing. What happens when they're crossing?
Cross out of the line.
They cross at a line, yeah? What did you...
the same point.
Yeah, I mean, you have two planes in 3D. When they cross, it means it's at a place where this plane exists and that plane exists. So it means that if a point is at the intersection, it's it's on plane 1 and it's also on plane 2. It means that both the equations for the planes are respected. It means we're looking for points that are on this plane and on that plane. So we're going to make a system with these two equations and solve the system. Does that make sense?
Yes.
Yeah. Visibly, there are other ways out there on the internet because many people did something completely different, which is also okay. But then this way is more related to our class. Something with taking the cross product of both normals. It's doable. But visibly, some people found that somewhere weren't very clear about what it means. Fair enough, I've never shown that. Okay. So the simplest way, the one we're going to use in this class, you're allowed to use the other one, but make sure you understand it. So to see where they cross, we're going to solve the system that's built with the two equations. Okay. Solve the system. Presumably, some people have copied that down. Can you repeat the equations? Otherwise, like any. The first one.
3 x minus 2 plus 4 y plus 3 and 6 z.
Plus 6z. Oops. Thank you. Is equal to 0, and then there's another one.
7 y x minus 1
X minus 1 plus.
5 y minus 7
Thank you.
and plus 9 z minus
Z minus
11.
11. Thank you. So we're going to solve the system. To solve a system, typically, the equations have to look differently from that. Do you know what I need to do to the equations first? Yeah, keep only variables on this side, and then on the right-hand side is only numbers. Yeah? Is that a question? Are you good? Yeah?
Why didn't we start with the equations that we're gonna get by distributing the numbers?
Why don't we what?
Don't we start with the equation we get when we distribute the numbers?
You mean at the very beginning up
Yeah.
here? Like starting with 3x plus 4y plus 6z is equal to something. You could have. It's allowed. One or the other, it makes no difference. If you do that, then you don't have to distribute later on. It's equivalent. This is the ones I've been using more because it's more obvious what the point is. But they're completely equivalent, so it's up to you. Yeah, because now we need to do it. That's 3x plus 4y plus 6z is equal to something. Minus 6 plus 12 is plus 6. Then I put it on the other side, should be minus 6. Does that make sense? Okay. Oh, okay. 7. Oh, can you put this in the calculator?
It gives 141.
141
Minus 141, and then when you put it
minus 7 minus 35 minus 99. That must be a minus something, yeah?
yeah, it gives minus 141, and when you put it on the other
It's
side.
141. Thank you, miss. Okay, now we can solve this. Gauss-Jordan. Okay, I'm not gonna do it all just because it's gonna take for absolute ever, and that's your homework anyway. But then, we're gonna try and solve this by Gauss-Jordan. There's only 2 equations, but there are 3 unknowns. So there's no way we're gonna find the identity matrix here. Even if we find 1, 0, 0, 1, then it's gonna be stuck left there. There's no way out of that. So we're gonna presumably the z is going to be a free parameter. So you can do this at home. Dot, 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 you solve the Gauss-Jordan with the Gauss-Jordan method, and you find something like this. A number, I don't know what it is. Let's pretend it's 3.1, and that's 5.7. Other numbers, 14, 15. I'm just pretending. We're nearly there. This you write back into the shape of a system. It's going to look like this. Those numbers are going to be different, but it will look like this. Z is going to be a free parameter for sure. So you call ZT. Don't forget this, that's 0.5. And then you're going to have x and y in terms of t, and then some numbers. This is just rewriting this matrix. And the last step is you have to use the system and write it down in vector form. And it's going to look like a line. That's the only step I'm going to leave to you. So write this in vector form, and it should look like a line. And what's the equation of a line in 3D?
X equals x zero plus t.
That's a huge coup. Are we okay? If you're not, you can use this at home. Hopefully, if this is recorded properly, you can watch this again. Okay. That was the way, kind of.